This conference will now be recorded.
Okay. Hello, everyone. Good morning, good afternoon, and good evening to everyone wherever you are. First of all, thank you so much for attending this online session on Oracle Exadata X8M Under the Cover by Karan Dodwal. On behalf of Nepal Oracle User Group, I would like to welcome everyone and thank Karan for accepting our invitation for the webinar. Karan is an Oracle certified master with specialization in Oracle Cloud, Oracle Exadata, and performance tuning. He works with Fidelity International as an Exadata DMA, database machine administrator. Karan is an author and active speaker in various events like Sangam, Uji Yatra, and others. And in his free time, he contributes to the Oracle community through different forums. I met Karan during OCM preparation class in 2013. He trained us for OCM. With his awesome tips and tricks, I was able to succeed OCM in my first attempt. And honestly speaking, Karan taught us to work smartly. Actually, I am not trying to please him, but literally, I was very much inspired by the way he troubleshoot the issue. I was amazed to see he had all of the Oracle command in his mind itself. Thank you, Karan, for the awesome OCM preparation class. My OCM was not possible without your help. And as usual, I would like to humbly request everyone to stay mute till the end of the session. You may raise your question via text in the chat section anytime, and we will grab them and reply them during the Q&A session. We will have a separate Q&A session at the end. In the same way, I request everyone to fill up the feedback form. We will post the feedback form URL in the chat section. And considering the current situation, we would like to request everyone to stay home, stay safe, take care of you and your family. And now, without further delay, I would like to hand over the control to Karan, and Karan will start with his introduction and exciting session. Okay.
Yeah, thank you, Dilly. Thanks so much for everything and for giving me the
You are
opportunity
welcome.
to speak on Exadata. So, good morning, everyone from India, and a good day to all of you in advance. So let's kick off, and we discussed that we will have the session first, and later on we'll of course have a Q&A, question and answers round, and we don't mind extending it if you have a lot of questions, and not just related to what's new in X8M, and additionally you have questions related to performance, like whatever comes in your way for Exadata, like storage indexes, smart scans, all these things happening under the hood when it comes to Oracle Exadata machine. Now I'm going to share my screen, and let's get started without wasting any time. So if you can see my screen, yeah, looks good. So let's start. I'm Karan. I work as an Oracle database machine administrator, DMA Exadata. So we manage Exadata and performance, and we are basically quite an old customer when it comes to Exadata. So let's get started, guys. So the interesting thing will be that what's new, as well as what is offered, as the best thing when it comes to Exadata, and how you guys can leverage the performance in Exadata, and what you guys need to do. Because the common questions come: how do I manage Exadata, and how do I manage the database in Exadata? So what additional skills I need, firstly, and what I need to do as a DBA. How do I create a database when I push a database from DBC as silent or whatever? What do I need to do? Do I need to take care of initialization parameters? Do I need to create a disk group with a specific option? What do I need to do? Yes, you need to take care of special parameters and attributes when it comes to those things. That's what an Exadata person would be or should be knowing. Network, storage, everything. So network and storage is one way, a good opportunity for you all to become, well, everything. Linux, you can become Linux administrator, because you guys, if you're managing the whole machine, you would have, the superpower access, the roots where you'll manage the whole network, the storage, and you can manage the whole, cell desks where you can, provision storage to your databases. So you have the control over storage. You have the network control as well, on the networking part as well, managing the network and tuning or opportunity to fix Linux issues or even upgrade them, right? So if Oracle doesn't upgrade for you, you have the privilege to upgrade. And patching would be, I would say patching will be a basic stuff, because patching has always been a basic stuff. I would say the level 1 stuff, because patching is always patching. It has never been complex. But other things like network and storage management, the configuration, the fixing of these issues has always been an interesting, challenging thing. Especially when issues come, some things are misconfigured and so on. Issues after upgrades and so on. All right, so let's kick off. And the most important thing is what's new in X8M. Now, we had a very brief meeting with Bob Thom. He's a senior vice president for Oracle Exadata product. So we had a very long discussion, and was there on the fireside chat with him, and he basically told us everything what's to be offered in X8M, which is again a new thing, totally new thing altogether. And you would see X4, X5, X6, but what's M now? You must be asking a question. Well, M is a special thing here. M would be Oracle decided to keep it for persistent memory. So the word M would be, so the letter M would be memory, but basically PMEM, persistent memory. That's the whole new thing, because it's a silicon technology offered by Intel. We'll discuss that, and it has changed the game. With not much cost, you get the performance, the I/O latency, much less as compared to traditional even flash cache, the flash storage as well. So it's much more, I would say the new thing, the next biggest thing, Intel has made it available for the customers. Well, not just our DBMS database customers, for big data analytics. It will change the game from now on because of its cost and the capacity it's offered. Make a note that persistent memory. Guys, I request everyone to keep yourself on mute. So the best thing about PMEM is that it survives the power failure. So it's persistent. The word is persistent here. Everybody talks about DRAM. It's good, it's fast, but does it, survive a reboot? Not at all, right? So now we have 3 tiers of storage. We have persistent memory, NVMe. Well, has been for a long time flash, and you have storage, typical storage. And we'll take questions after the session, so not to worry. I know you will have a lot of questions. So allow me to finish the agenda, then we'll have a lot of questions, and we'll enjoy all the brainstorming. And the most important thing is as well that because we have the new Rocky networking part, the network fabric, is RDMA over converged Ethernet. Because as you know till now, because see, even before X8M, there was X8, X7, X6, typical. There was no M before that, right? So we had InfiniBand, as we all know. So now what we have is we are leveraging the RDMA, remote direct memory access technology, right, over basically the Ethernet, because the industry is changing. Everyone, especially the customers who can afford. So we are moving to all of us are moving to RDMA over converged Ethernet. The benefit is that gives us the ability to use Ethernet as well as the RDMA over Ethernet, right? So if you typically go back to let's say a few years back as well as today, we have fiber channel over Ethernet. You would see FCOE adapters, right? So every host or every server will have an adapter, right? What's the adapter? Typically, you can think of it like a NIC card, of course. like even our laptop has a NIC card. So it's an adapter basically, which allows you to talk to storage servers via switch. And that switch can be SAN switch, fiber channel switch. In this case, it will be a Rocky switch now, not an InfiniBand anymore. So when it's Exadata, it's either InfiniBand or now our DMA over converged Ethernet. So what we are trying to do here is the RDMA technology since long time, what it does is it bypasses the CPU of the server. It bypasses the networking interrupts, context switches, everything. The total overhead is eliminated. What happens, the application, or in other words, the remote, let's say the remote server, right, can actually read the data directly from the card. Your card, basically, yeah, in older version, it was host channel adapter, HCA ports, right? But now it will be basically RDMA or Rocky ports, basically. So the ability to read the data directly from the card, right? So the card has the capability. So the card has the capability to read from the memory or even write to the memory, bypassing the operating system overhead, CPU as well, bypassing everything, even the context, which is not at all, no overhead at all. So that's the technology, basically, what we were trying to leverage with. And going back to basics, yeah, Exadata offers, well, previously Exadata was designed for warehouse. Now it is for everything, even your mixed workloads, your transactional as well. So we have a scale out architecture. We are able to leverage the entire storage array, and the performance comes with a typical hardware and the smart algorithms which Oracle has basically developed over the years, since more than a decade now, right? Via ExaFusion protocol, smart scans, all these protocols have been developed by, Oracle with the help of the vendors, Intel and all these vendors, networking vendors as well. So it's simple and fast to implement for sure. Now, when it comes to X8M, we have, of course, persistent memory now. And if you can see here, the persistent memory, well, 1.5 TB, 1.5 TB basically per configuration. But when it comes to the whole, capacity, well, it depends which capacity you are using. Are you going for high capacity? Are you going for extreme flash? Now, extreme flash is a different configuration where you have everything as flash and limited amount of persistent memory, right? So if you can see here, we have 153.6 TB for flash and 4.5 TB as a persistent memory when it comes to extreme flash, right? So it depends where you are, right? Whether you are 1/8 rack or quarter rack. 1/8 quarter rack and 1/8 rack and quarter rack basically is the difference that half of your cores are disabled, isn't it? And again, quarter rack will be your cores are double, right? And again, licensing and cost and everything, half rack, well, full rack, we have 14 storage servers and 8 database servers and beyond. Then you have elastic configuration as well possible, right? So the storage, now, of course, you can get all these things in the Exadata data sheet. So whenever you go to visit Oracle website, just look for the data sheet for every Exadata machine. You get every single piece of details over there, how much capacity it has to offer, right? And so you can always go to machine-specific data sheet, because actually every machine of Exadata comes with as well your 2-socket or 8-socket, right? So if you say X62 or X68, right? That what is that 2 and 8? That's actually the number of sockets. And when you talk about socket, it's about the number of cores each socket can have, right? So the more CPU capacity is available and better hardware or more hardware you have when it comes to 8-socket systems. So always visit the data sheet, right? If you have if you need it, just let us know, and you can always find on Oracle portals the data sheet. So that's the information you can always find, how much capacity and how many number of disks, how many flash storage you have. It depends on the number of flash cards and how much PMEM we have now. So yes, the major enhancement has been persistent memory and Rocket. Well, I'll come back to that slide, by the way. We have unique software algorithms which implement the intelligence under the covers, and persistent memory and Rocky has been the new ones. Now with the with basically the PMEM, the persistent memory offered by Intel, the silicon technology, you won't believe, guys, from 200 microseconds, a single write to the storage can be just under 19 microseconds. If you always have if you have ever used an AWR report, even though you don't have root access, you can always get an AWR report of Exadata. You would see the latency every storage cell has to offer, and you would see a very smart, metric, or I would say the statistic is what is the average latency of your cell, right? So, and especially the log write, because when PMEM was not there in X7 and X6, basically, so there was flash and you had flash log. So the log writer would like to write to flash log. So you would see how many microseconds it took, roughly close to 200 microseconds, right? You would see that literally the value. I wish we would do an Exadata performance session. I would show you that. I did that in Sangam, how to interpret Exadata specific AWR. But because see, why I'm telling you these things, it's no big deal. Yeah, it's offering this much number of latency, let's say 200 microseconds. But when the issue comes, let's say your cell has a problem, or there is some problem going on, there's too much of workload, you would see that latency getting increased, and that's where you start solving performance issues, right? That's fine. Everybody can go to AWR and become happy that it's offering 200 microseconds. But when you have to solve an issue, you have to look at those numbers. It's not always about bad execution plan. It is about checking those deviations when it comes to the problems when we encounter, right? So we have ultra fast log writes to accelerate transactions, and we have 560 gigabytes GB per second. And if one would surely note that from now on in our DMA over converged Ethernet, we have 100 gigabits per second as compared to 40 gigabits per second offered by conventional InfiniBand in Exadata. So the Rocky networking would offer, remember, 100 gigabits per second. Let me just show you. There was, this one. So the converged Ethernet for, our DMA over converged Ethernet, the Rocky switches. So of course, in a typical Exadata machine as well, you would see always you have two leaf switches, InfiniBand leaf switches or Rocky leaf switches. You have another switch, special switch known as a spine switch, which is required basically when you, let's say you want to connect two racks, right? You would have them in the full rack, especially. You would not have them in quarter rack, let's say. So spine switches are required, especially when you want to have huge amount of machines, right? And you want to interconnect them. You would do that with a spine switch. That's why you need a spine switch. That's a common question which come to me. And so this is our DBA network switches, if you see here. So of course, you will have a typical Ethernet switch, which is used by, let's say, the management network. Every infrastructure has a management network. What is the management network? If you go wherever, like vSphere, in a data center managed by a software, which is a hypervisor, or everywhere you go, you will have a management network. What's that management network? You want to monitor your stuff. You want to monitor your switches, you want to monitor your compute nodes, you want to monitor your storage and all that. Yeah, that's why you need a management network. And you would not use that for, you would not use management network with an expensive switch. You would have a typical Ethernet switch. So you would have a management network always to manage everything, even the PDUs and everything. So yes, you can come via client network. It depends what are the options you have. You always have a spare port available. ILOM ports are there. You have spare ports available, and you have a spare port, of course, where you can connect to a backup server, right? Let's say you have a backup server running somewhere. You have a ZFS appliance. You would like to connect that, so you'll use maybe Net3 or a Net2 or a spare port, basically Net3 or Net4, because Net1 and Net2 are typically bonded for client public interface, right? So that's how, because public interface, of course, would be for client connectivity when you connect to a rack network. Let me come back. Yeah. So this is the whole new thing, persistent memory, right? So if you can see here, this is additional tier now in the storage completely. The technology works this way, is that we bypass everything related to the compute node, the overhead basically. the CPU, the overhead, basically the operating system, because operating system overhead has been, a very significant factor. And now you have, no CPU, basically intervention, no context switches, no OS involvement, direct write to the persistent memory, right? So this is something. Now you will have your log writes happening here. You would want them actually. So just like similar flash logs, again, you could control that via IORM. With IORM, you can control that, right? So similarly, because you would like to say, okay, this is my database, mission critical database. I want 1 TB of flash to be used. Similarly for PMEM. So you can control, you don't want your basic database, which is a dev or a UART, to use this, hot stuff, flash or PMEM, right? You could always control that for sure via IORM, right? And you would want your hottest data, or for mission critical databases, log write directly to go to PMEM and then transferred, to persistent memory, persistent, I would say disk. I would say magnetic disk, because eventually your log files are on hard drives or magnetic disk, rotational disk, because rotational disks are typically slower as compared to flash and persistent memory, where in a hard disk you have, the time to position the head, and the rotational latency, because hard drives are a little bit slower, that. So we have, again, that depends on the performance of the hard disk, whether it's a 15,000 RPM hard disk, whether it's a 6,000 RPM hard disk, 7,500 revolutions per minute hard disk, again, all that bottleneck of storage. So magnetic media, that's cold, right? So that's basically PMEM. We won't, again, spend much time because there are a lot of things more to cover when it comes to, X8M. So in simple words, guys, we have persistent memory, basically, and we have, it's a new silicon technology, fine, the distinct storage tier for performance, capacity, and the price. The price is usually between DRAM and flash, so that's why it's not expensive, right? And with X8M, we have 1.5 precision memory to the extreme flash and high capacity storage servers. And if we read the data with the speed of memory, basically, so the reading speed is as the same as DRAM typically, and it will survive power failures. The writes basically will survive power failures. Well, in combination with RoCE, the RDMA over converged Ethernet, which offers 100 gigabits per second. Please note the difference between 100 gigabits per second and bytes per second. 1 byte has typically 8 bits for sure. So if I'm talking about the conventional, let's say InfiniBand, it's 40 gigabits per second. If you divide by it, that would be 5 gigabytes per second, right? So when I say that 100 gigabits, it's always bits I'm talking about. You would divide that by 8, right? So that's what we are talking about here, right? Coming back, and if you see here, the commit accelerator, your log writes will directly go to the persistent memory. That's the whole change, or big change, I would say, given by Oracle or done by Oracle with the help of Intel. So it's a Intel Optane technology offered by Intel in Exadata. So one interesting thing here to understand is that because InfiniBand, now some customers use hypervisor virtualization. Traditionally, you had Zen hypervisor. Now, no more Zen hypervisor, because again, there are things that, yeah, InfiniBand doesn't support Linux KVM, right? So now RoCE network fabric supports Linux KVM. So in the future, if you are implementing virtualization, you should know how to work with Linux KVM, right? Linux KVM will help you to provision virtual machines on Exadata. So that's another skill you should have. If you don't have, you should have, if you are managing virtualization, VMs, right? If you're familiar with other, like VMware hypervisor, vSphere hypervisor, that's the name of the product. But yeah, VMware is the number one, I would say, the number one vendor for virtualization. But Linux KVM is actually, basically is actually the hypervisor which is available on X8M, right? So now you would use Linux KVM only. When I use the word only, that's the only thing supported now, no more than hypervisor, right? So it has to do something with support for bridging connectivity, and no support for InfiniBand. So Linux KVM works only on Rocky network, right? This is something which a common question I had was, can you connect a Linux KVM running on with Rocky, and can you have a standby database on a InfiniBand while using Zen hypervisor? Well, yes, you can, right? So this is a common question: interoperability, right? So you can connect or let's say have a DR on your old machine, because some customers still have their X6 or X7s running or X5s running. We still have seen a lot of customers still using X5s. So you can still have your DRs available on the older Exadata models, where you are using maybe Zen, or of course, or maybe physical altogether, right? So with InfiniBand, only Zen is supported, and with Rocky, you can use KVM, because virtualization is again the next biggest thing which customers want to use for consolidation. So that's another skill which you should have, I would say, virtualization. And now quarantines. Well, we are in quarantines these days. So that's a good thing to discuss. So everybody knows what is a quarantine then. So well, in Exadata, we now in 19C, we can even quarantine SQL execution plans, or we can actually say if my SQL elapsed time is more than 100 seconds, right, or maybe 50 seconds, I would like to quarantine that execution plan. So Oracle would not use your SQL for that plan, or we will not use that plan for that SQL, right? So we basically get rid of that plan ever. We will not use that plan at all, right? Because we would like to use a better plan only. So that's what customers want sometimes, to quarantine a SQL rather than using a bad plan. Or think of it like parallelism, right? If there are no parallel slaves available, I don't want to use it, right? So there's a parallel, initialization parameter that controls that, right? So something like parallel minimum slaves available is the init parameter which controls that, right? So similarly, we have quarantines there. Different kinds of well, by the way, why I'm telling you that is because now X8Ms will have 19C software only, 19C or 19.x database versions, or even grid infrastructure, right? So these features are available there, right? So of course, the best features are only available on Exadata. That's why you would want Exadata for that reason. So all the best features, autonomous indexing, right? Your fast ingest, all those features, quarantines, all these features are available in Exadata only. Right? There are a lot of those features, by the way, in Exadata. So only in Exadata, I should say. So that's big reasons to use Exadata. So this is interesting. We have course quarantines as well. Now, this is something which we are talking about here. Is one are SQL quarantines, right, and one are the Exadata quarantines. SQL quarantines will say that, okay, don't use this plan if my SQL takes more than this much CPU or elapsed time. But Exadata quarantine is that sometimes problems happen, right? That's where DBA is required. So if I would say, if there is a problem for this SQL ID, when it fetches this particular ESM allocation unit in this particular cell, I would like to quarantine that. So I can have a quarantine for a cell, right? I can have a quarantine if my, I can have a quarantine if my SQL ID is this, for this particular plan, I can have for this table or index. Let's say this query has a bug when it uses storage index, right? So what I will do, I would have a quarantine for that. Well, we can do that. A container, database, SQL plans, right? We have another kind of quarantine, which is fine-grained quarantine. Now, when I say a fine-grained quarantine, what we are trying to target here is basically, unlike course. So course-based quarantine, what it would do, Excuse me.
Karan, Satish, sorry to disturb you. Karan,
Yes, Satish.
this SQL ID quarantine, it means it will collect the bad execution plan and it will not execute it again, right? Quarantine in the sense SQL ID quarantine means like it will collect the bad SQL plan and it will not be used.
Yeah, so I'll take that question in the Q&A. We'll come back on that. Basically, yes, we quarantine a single SQL statement. So there can be two things which can happen here. What we are trying to say is we want to quarantine a SQL plan when it takes more than 100 seconds. If it's executing in 10 seconds, that means it's using a good plan as compared to 100 seconds. Must be, let's say, index scan. So obviously, more than 100 seconds would mean a bad plan. 99% of the time, unless there's a your server is in a bad health and other things, right? So that's one thing. Other thing is the problems with Exadata hardware, let's say, or a bug which happens with Exadata cell software, right? So we are talking two things here, right? But I'll take that question in the Q&A because that requires a little more explanation. And another thing which, yeah,
great.
So
another
thing, yeah, thanks, Satish. But we'll definitely would like to take that in a Q&A as well. Feel free to please come back. And we added, basically this, a very unique thing which we can actually add is that, yeah, SQL ID and filtration, DB unique name and all that, right? A fine grained is for, I would say, mostly for test purposes, or you would like to, target basically compression. Okay, and you OLTP compression, Bloom filters, chain rows, decryption. Sorry, a few hiccups. Right. So okay, so yeah, some customers would like to compare. Okay, let's say I as a customer want to compare. Okay, if the SQL doesn't use a Bloom filter, what would happen? Chain rows, decryption. As compared to encryption, ESC, hybrid columnar compression, you can always do that. Yeah, so there are quarantines available. Question is, how do you do that? Yeah, you can always do metalink search and all other searches on other search engines, which you do, but this is how you do it. We always good to go to CellCL and use help quarantine, where you can actually create a quarantine based on, you can give a name to a quarantine plan and you can give, let's say, SQL ID, quarantine plan name, DB unique name. Now, DB unique name is something which you have to take care because we can have same database name sometimes, so better to go for unique names, and that's what Oracle expects. That's a common question which comes to me. I had a question even last week as well from a guy. He said, I want to alter IORM plan. Should I use DB name or unique name, right? So it's interesting, right? I'll take that question in Q&A. So it's interesting, these things, what I should use, because you would put a, let's say a DB name or a unique name, and you see your performance is still not impacted, right? So that's what you have to see sometimes, that why it's not working, because sometimes there are other factors which controls that. But we'll take that in Q&A. By the way, let me just go back if I missed something when it comes to X8M. The major, oh yeah, one more thing. Well, this was covered by Anil Nair already. He was, what a wonderful session on Rack he gave. We still have a video available on AIOG channel. He mentioned about node eviction. So in Exadata, especially, a node eviction can be detected under 1 second. How is that possible? Now, going back to good old days, 9i, 10G rack, and so on, where we used to do a lot of hard work to configure rack, I would say. Today, we hardly have to do anything to, push a rack installation. So now, a node eviction, how does it do? We try to ping a node, right? I want to ping my colleague, who is my node, let's say. We have 2-node cluster or 3-node or 5-node cluster. So I ping my node member, right? I don't get a response, right? So all those factors come into picture, right? Voting disk, kill block, all those good things we used to talk about a decade ago, right? Voting disk heartbeat, network heartbeat, and all that. Sometimes, guys, what happens is your CPU of the host is busy, right? Your health of the system or server is bad. You are swapping a lot, your memory is, is dying of the box, right? Someone, provisioned your box, and there's a bad plan, let's say, and SQLs are doing a lot of sorting, swapping is happening from, by less PGA, let's say, or whatever, right? Your node is not responding, in simple words, right? How do you detect that? So what Oracle Exadata does is we try to do 4 pings with the help of network cards. So think about that. 2 nodes are trying to get a response. Now each node is dual port, right? Which is, of course, every customer would have dual port. You won't have a single port, and if it dies, you are done. You will always have dual port, 2 ports. So the neighboring server, what we do is we ping basically both the nodes via each node. So if you see here, server 1, NIC port 1 pings NIC port 2 as well as NIC port 2 of the neighboring server, and similarly done by the NIC port 2 as well. So in total, there are 4 pings. If immediately, now this is what we are trying to do, is we are doing a hardware check. Okay, they can be exceptions we have seen in the past, that the firmware hangs after InfiniBand patching or patching went wrong. The firmware hangs. That's another thing. But typically, your hardware will be fine, and a heartbeat will come for a port from a port, right? If your server is bad in health, but the port will respond. That's what we are trying to do here, right? So if all the 4 responses come back, your server is alive, right? If one of the ping does not come, the server will be evicted, right? That's how fast it is. Under 1 second, we will be able to detect the instance failure detection, and node will be evicted, right? So refer to, again, you don't have to do anything, but yeah, if you want to listen it to again, yeah, we have Anil Nair's webinar where he covered that. He's a Rack Master Product Manager, and what an amazing webinar it was, right? So next generation rack it was. So yeah, that was the Linux KVM, only available on Rocky networking. And coming back, we were, yeah, autonomous indexing. Some of you might be not aware of this, but yeah, it's simple that you don't have to do anything if you implement this feature. So you can have 3 options. One is not to use this, not to use this feature at all. Second is to use it in report only mode. The third is to implement it. By reports, if you report only, you can view the cool reports where Oracle recommends you have this index. If it was used in the where clause, we found the index as a better plan, and so forth, right? So in implement phase, right, you would you don't have to do anything, but in reporting phase, you can always read it, right? Read the reports and recommend to your developers as well, right? So Oracle under the covers, what it's doing is it creates an invisible or and unusable indexes. Invisible and unusable both are different things, by the way, right? In 11G had this new feature, invisible indexes. So both are different things, right? So and now Oracle does a hard parse, and then we rebuild the index. But after making it valid, we still make it invisible because we don't want it to use it because it might be bad for performance. We execute the statement, right? Then what we do is we make it visible, right? And see if it improves. Now, if it is bad, so Oracle, always compares the original plan with this new plan, which was observed in this workload of yours. So if it was found 3 times better in terms of IO, CPU, and buffer gets, all 3 cost factors will be considered, right? Buffer gets, every buffer get is a cost. Guys, please make a note, because when you access a buffer in the buffer cache, you need a CPU, you need a latch, you need a buffer latch, and that requires CPU, right? People say, okay, I say alter table keep, or alter table cache. Well, those are different options, by the way, and they have a different meaning altogether. But it has a cost, even though you cache a full table, because a full table can read one by one all the buffers, right? So every buffer has a cost as well, every buffer read. And then it comes to your CPU cost as well. And finally, IO cost. IO is another important factor here, right? Of course, with more memory, you can have less IO. That's another thing. But and if Oracle finds it to be a better plan, we make it permanently visible. Otherwise, we mark it unusable. And yes, in 19C, you have this in Exadata feature available, but you can mark it. Basically, you have options that I want autonomous indexing only used for my particular schema only. I can have this particular table space for autonomous indexes, right? And I want to purge my indexes after 6 months if they are unusable, because the blacklisted or unusable indexes won't be used, right? So after 1 month or 6 months, you want to drop them. So there's a retention period, which you can configure easily. Want to worried about how to find them? DB indexes, just say where auto equals to yes. It will list your autonomous indexes. They start with AI, autonomous indexing, AI. They start with AI. Manual indexes can also be purged automatically based on the same retention period. Right. So, okay. So execute statements then based on these factors. Now, yes, smart scan is always available, has always been available, right? So common thing is, how would you find that? Now, when you migrate to X8M, or of course that's the latest offering by Oracle, right? You would compare your workloads. Right? And a lot of people get performance issues after migration. How would you do that? How would you deal with these things, right? The customer is saying there is a performance issue after migration into Exadata. How you're going to deal with those things, right? The first thing is always use SQL plan baselines, which I always say. Suddenly you don't see your SQL plans baselines being used, will go for evolution. They will be used, right? That's the best way to go to stability. You can't just say, tonight we are migrating to Exadata. Hey, Karan, in the morning 6 a.m. I will have a smart scan execution plan. Well, not quite, because that's not a good thing to do, right? Because what you should do is initially use baselines and slowly take baby steps weekly, follow approaches, okay, 20 SQL IDs or 30 SQL IDs weekly, or a schema wise basically, and then compare the plans. I always say that, let me come back to that slide. I always say, I have a common question. There was a very good session from Arup Nanda in Sangam 2 years back. Should I drop my indexes in Exadata, right? So the first thing which you should do is invisible the indexes, because you don't have to drop it. When you drop an index, it can be a carnage. There will be a lot of redo and undo generated, right? You don't want to do that. Just make it invisible and see a smart scan comes in and how's the performance. If found better, pin that plan. Pin that plan by a profile or a baseline. It's up to you, right? But the best practice is go for profile. Why not baseline? Why profile? Because baseline locks a plan, but the profile gives the optimizer the ability to get more knowledge. And that's that won't be a forced plan, the profile, right? So plan will not be a forced plan if you profile it. Profile is the better way to instruct the optimizer, give better information to the optimizer, right? I agree baselines is good for stability, but profiling is one way that you are not locking a plan, unlike baseline, but it's indicating optimizer with more information, right? And see whether smart scan or a smart scan improves performance or not. That's another big talk altogether. And see how your Exadatas behave, or your SQL behaves in Exadata, right? Exadata will behave well, but you have to see whether smart scan defeats index scan or not, right? That's a common question. Index versus smart scan, which is the best? Well, smart scan is not always the best, right? So yeah. So they are not always the best. That's the naked truth. So you have to compare. You still have to live with your indexes, most of it, if not all. You would see some percentage of smart scan are much better. Okay, you're creating a disk group, or you're creating a database DBCA. What I have to do in Exadata, X8M, or whichever machine comes your way, right? So allocation unit size must be 4 MB. Now this is the value you have to put only in Exadata, right? So you would see your Oracle engineers visiting your site and doing the Exadata installation, right? Under the covers, you would see they will put these values, and you would never know what's happening, right? These are the things which happens under the covers. By default, allocation unit size is 1 MB. And in non-Exadata, you have to live with 1 MB only, because 4 MB is only good in Exadata, right? So this is what you have to do, right? These are the design technique benchmarks have shown that this is the best value in Exadata. Because, see, frankly speaking, why these things matter? Because ASM basically has a SGA. It has shade pool. Everybody knows that. If you go behind the scenes, you would see ASM shade pool is under pressure. If there are a lot of ASM extents or allocation unit size, right? And all these things matter. Some customers have a lot of disk groups per box or per I would say per rack configuration. Never do that. If I have 50 disk groups in a rack cluster, that won't be good for performance, right? Because consider about the metadata ASM has to keep, right? This is why in Exadata, you would see just one disk group for database storage, only data, even though you have 20 databases. That's the best practice. Less metadata for ASM in the shade pool, right? You could, because Oracle could have said, okay, go for 20 disk groups per database. No, never do that. In Exadata, you would see only one disk group, right? So if you're planning to have 50 databases in a rack cluster, small databases, never go for individual disk groups. Have one disk group only and leverage the entire storage array, right? No harm. But yeah, sometimes we are limited with, your mirroring capabilities. This is my disk group for this database. Is not that important database, just a dev where we have incremental backup, fine every day, that's fine. I want external redundancy, but for mission critical, I want not high redundancy. But again, those are another thing, right? But yeah, these are the best practices I'm talking about, right? So some customers have write back flash cache preference. They prefer performance only. No matter what happens, my performance should not degrade. Go for write back flash cache, because by default, write through flash cache is enabled, right? So if you're an extreme flash storage customer, yeah, you would have everything as flash. But if you have a hybrid configuration where a typical, Exadata, high capacity storage, you would have mixed configuration. You have limited PMEM and limited flash, right? Couple of terabytes, right? Up to, I would say, around 4 to 5 terabytes, and if it's flash, yeah, you would see more than that, more than even 10 terabytes sometimes, depending on quarter or half, or even full rack. So then you have magnetic disks in a mixed configuration. So what we're trying to do here is in write through, which is the default, your write goes to magnetic disk. When your write goes to magnetic disk, it can slow down the things, because the hard disks have a disk controller, and the disk controller has a cache. Right? Depends what is the cache size. In the old days, there were like few MBs. Now we have 1 GB of cache, but that still can be, saturated. So we have seen customers doing 50 GB inserts. In a single insert, they're doing 50 GB insert. That's massive. For those kind of inserts, you would see free buffer weights in the AWR report, right? So for those customers, you have the ability to configure write back flash cache, where the insert directly goes to flash cache rather than the hard disk, right? So, but yeah, then your insert will also go to flash. So your read as well as write will go to flash. So you need enough, good amount of space there, but you might prioritize one or two databases there, but you will have amazing performance, especially for write intensive workloads I'm talking about. If you don't have write intensive workload, don't go for it. Your write through will still be better. But if space is not a problem, let's say your database is just a couple of terabytes, well, good enough to go. Good enough for write back flash cache, and you will see the performance and benefits, because especially when you want insert intensive application. But now X8M is in the picture, you might not need it. Of course, why? Because you have PMEM, persistent memory binding there, right? So your insert or log write will be under 20 microseconds. From 200 microseconds, we are down to 19 or less than 19 microseconds. right? So it's 10 times more improvement in the IO latency, right? This is the biggest change along with Rocky networking, which X8M has given us, right? Because if you see, talk about log writes is the most critical part, right? Now now, do you ever know? Because everybody knows when a log writer writes at every commit, 1/3 of the log buffer at every commit, right? So, or 1 MB, and the log buffer is 1 MB full. But there's a special condition in rack, right? When a log writer writes, what's that condition? Anyone knows? The special condition is that when a remote node requests for a exclusive block image, right? The local. So of course, let's say you have a 3-node cluster, right? Node 1 is the master, node 2 is the requester, right? And node 3 is the holder. So node 2, the requester, goes to the node 1 master, right? And says, hey, master, I need this block. So the master instructs to the node 3, who is the holder, that Mr. Node 3, transfer the block to node 2. That's my instruction to you. Because I'm the master, I know this block is with you, kindly transfer, right? Now, before the node 3 holder transfer the block to node 2, it has to flush the block to the log file, to the persistent storage, right? That is why the log writes are critical in rack, especially, right? Good news for you in Exadata X8M is that we have a new enhancement now, is that because now we have so fast log writes, and now we even have Exafusion protocol. So rack interconnect messaging, especially the exclusive block image transfer, your undo images, right? They are transferred without disk acknowledgement, only in Exadata, because of this Exafusion protocol, right? So think about it just like fast sync. You don't need a standby disk acknowledgement, right? From primary to standby, you need acknowledgement, right, from RFS, right? Whether it's written to the disk or not. That's basically your sync affirm, right? When you don't need it, what you will say, sync no affirm, fast sync. So something similar to that. I'm not saying it's the same case. Something similar to that, right? So via interconnect, your undo images is very critical in rack, right? Your network heartbeat, which rack has to do, right? And the exclusive block transfer images, these are prioritized in Exadata now via Exafusion protocol. Anil Nair mentioned that, by the way, and that's something which is, again, since quite a long time. Exafusion protocol, it's even in older X6s, X7s, and what's new in X8M is you have a faster node eviction. If a node eviction ever has to happen, by the way, you would still see a node reboot occasionally. Occasionally, of course. I'm not an Oracle employee who will say it will never happen, but yeah, I won't say it happens even annually. It might happen in 5 years maybe, or I don't want to say a lesser duration, because that's how your Linuxes are. But yeah, sometimes there are bad days. Another thing which has been a long time from Oracle, that your allocation units of ESM can be eliminated. So if let's say I want to read something, okay, so yeah, I want to read, let's select star from table, and so if you can, by the way, it's in the slide as well. If I say select star from T1 where B is less than 2, right? So in the cell memory, your cell storage, everybody knows, let's say quarter rack, you have 3 cells, right? In every cell you will have a memory, of course. These days storages are so smart, they have their own memory, they have their own CPU, they have their own operating system, right? That's what Exadata cell storage is as well. So what's going to happen, you will not have benefit in the first hit. In the second hit, Oracle will know the minimum and the maximum value of the column, and the maximum and minimum value is a very light metadata, isn't it, guys? Right? So this information basically will be kept in the memory. And now you see here, so now what we are trying to say is here, for each allocation unit of ESM, right? For each allocation unit of ASM, we are doing this. So if I have, let's say, 10,000 ASM allocation units, and I say select star from T1 where B is less than 2, well, I have the data in memory. Can you see like a cloud, it's made? So that's a region index, it's written, though, so it's again a storage index. So it's in the memory, very lightweight. So I know that in the allocation unit 1, minimum is 1, max is 5, right? So I just read the first allocation unit and I skip the second, third, and all other thousands of allocation units. So this is just like you go to college, you go to school, you know where your class is, so you skip all the classrooms where you don't have to go. You save your time, right? You just enter or hit the classroom where you have to go. You skip other unnecessary classrooms where you have to go. So you are skipping allocation units which you don't want to visit. Simple words, in simple words, right? Don't confuse this with smart scan at all and index scan. Those are another stories, and this is something which you get as an added benefit. Getting my point? This is an added benefit. I'll repeat once more. You can have a smart scan with this storage index benefit in the same query hit if you're lucky that you ran for the second time and your minimum maximum value helped Oracle, and you can get this benefit even with the index scan as well as a full table scan. Right? So this is additional benefit you get in Exadata. Not that it's replacing smart scan or index scan. Why I brought this slide is it's a typical confusion in the world right now, right? People still say, okay, storage index and blah blah blah. That's not at all. Index, storage index, index scan, storage indexes, and smart scan, all three are different terminologies. If you have any questions, I'm available for that, right? Dili, can you do the next slide? Let me see if anything is left because we are almost done. And IORM, okay, interesting. Okay, IORM, what it does is basically, you must go for IORM. I must tell you that because you will be having more than one database, right? And you want to decide the business priority of which database should have more IOs or given more shares to the IOs. So what happens is in the disk queue, when you are about to do a full table scan, you will be in queue if you're not important. Simple words. The important guy will be first and he will read the data first. Simple words, right? How you do that? Okay, I covered in another Exadata IORM, but I have a very good thing that next slide covers that, by the way. So you can actually go to the next slide now. Thanks, Lily. Thanks for all your help. Now, okay, so what's happening under the covers is you create categories, right? And so categories will decide which category you belong to. How do you create categories? Well, DBMS, there's a DBMS underscore category function. DBMS basically resource manager create category. So with PLSQL, you create that. If you want exact syntax, I can share that. Just write an email, we'll share with you. So yeah, so you create a directive. Oh, sorry, category, not a directive. Yeah, it will be you would call it a plan directive, by the way, if it's a IORM plan. So now you have two things now, typical resource manager plan and an IORM plan. IORM talks about IOs only, right? Or limits you with IOs only. So after your categories decide, so that means the first filter is done on the category itself. The next filter is done on the inter-database level. So if you're part of interactive, you are most welcome for 60% of shares. Next, we check inter-database plans. Inter-database or the dev or finance of prod versus finance. So if you're a part of, let's say, most important database, you get more priority. But remember, let's talk about database A on the right side, interactive category. So if you see here, database A on the right side of interactive category gets 70% and database B gets 30% of the interactive category. But remember, the 70 and 30% is of that 60% which was given in the first filter. After the inter-database plans, we check for intra-database plan. What is intra-database? Intra-database is within the database. So let's say I have a username Karan, I have a username Yogi, I have a I have a schema, basically, it's a schema preference. And schemas or services, they map to resource consumer groups, right? So so isn't it, guys? So that filter inside the database, how important you are, right? So, and then eventually your IRMs are allocated, right? So what you've done, this math is, it's very interesting. So in the intro database, if you see here, 15 plus 10, right? 15 plus 10 would be 25, right? And if you see database A, again, from left to right, the third column, 35 plus 40 would be 75. So 75 plus 25 would make 100% IOs. We took a look at second column database B, 22 and 18%, that's 40%. And on the fourth column database B, that's 45 plus 15, 60. 60 plus 40, 100% IOs, makes it for the whole database. And eventually, when you sum up the last IORM allocation, which eventually you get the IORM allocation, 16.8 plus 11.2 plus 6.6 plus 5.4 plus 19.6 plus 22.4 plus 4.5 plus 13.5 makes it exactly 100%. If you have a calculator, check it. Okay, so this is something which happens, this is something which happens again on the fly, where your IORMs will be checked, right? So this is again IORM. Dilly, can you go to the next slide? Okay, okay, this we covered. Write back flash cache. Next slide. Allocation need to be covered. Index usage we cover, invisible and smart scans. Extent size, guys, for the best practice, go for initial 8 MB. Initial 8 MB, next 8 MB. That's the best practice for table spaces and tables, because it's for the alignment of your table spaces. Basically, your alignment with the disk groups, because disk groups has 4 MB. So for that multiple factor and good in alignment and better ASM shade pool performance, we'll go for that. Next slide, please. Exadata system specific statistics. When you migrate to X8M, right, or in any Exadata machine, I would say, make sure you gather this. Your optimizer should know you are in Exadata. If you have missed this part, gather system stats with Exadata, right? Don't expect good optimizer behavior, right? So you must use this, especially in Exadata. Your optimizer should know you are in Exadata, because Exadata optimizer is totally a different world altogether. A lot of things happening under the covers for optimizer, right? So make sure you do it, right? So and because why? What you're doing, your optimizer should know how much time it takes for a CPU time and your IO time, right? So your optimizer will have better knowledge, because in Exadata, it's a totally a different world, right? Even though you call your typical warehouse systems as the best ones, where you have Flash from Dell, where you have Flash from other vendors, Exadata Flash is a lot of times faster as compared to AWS and Microsoft Azure Cloud, right? They don't offer 19 microseconds of log write. They don't offer those smart features of storage, right? You have to do that, by the way. Next slide, please. Okay, great. So we covered on time. Q&A. Thanks, Dilly. Thanks a lot. Everything. Great, guys. So right, great. So see how we saved, because I was actually worried that the laptop crashed and we'll miss the session, but mobile helped a lot. Thanks, and Dilly, thanks for your help for sharing the slide deck, downloading it quickly. So guys, I'm available for Q&A. How many people are connected right now, Dilly? On the can you see on the panel?
Karan, right now we have 51 attendees connected.
Okay, cool. So, oh, great. So we can have a lot of questions, guys, if you want, because I have already, as promised, I've crossed my 1 hour of time already. I'm happy to answer anything.
Karan, Hariyar here. Okay. So even though we said this, resource manager plan, okay, we said that resource manager plan, but because of one application, okay, is because of heavy loaded on application, it affects the entire database on that cluster. Okay, so how I can control in that cases?
I'm sorry. Would you or you mean a resource manager plan?
Yeah, I said on resource manager plan for one database. Okay,
Okay.
and let's suppose for that database, because of very heavy application uses, it uses excessive CPUs and PGA and IO uses for that one database.
Okay.
Okay, because of that, it affects the entire database. Let's suppose I have around 40 database running on that box, so it affects the entire database.
Okay. So you can easily do that with resource manager. You don't need IORM here. So if you're talking
No,
about CPU, and what I understand from your question is, so
uh-huh.
what I understand. Okay. Yeah. Please go ahead. Sorry.
So even though I said that resource plan, but still it uses the more CPUs from the that host from that box.
Okay. So see, if your query uses a lot of CPU, obviously you first
Mhm.
have to check its execution plan. Why it's using CPU? First thing, because you can eliminate a lot of CPU just by tuning the query itself or the plan. Okay, fine. That's first thing. Second thing is, yeah, if okay, let's say plan is best in the world, still you have a lot of CPU. You can't do anything about it. It's just select star from table. Select star from table, nowhere close, nothing. Now
No,
you
no.
are
My
asking
question
what to
is,
do.
yeah, my question is, even though I given around 40% to use the CPU for entire this box, so why is using the 100% of that CPU? Means in the sense, I make the plan like a resource manager plan and give only the 40%. Please use the 40% of this whole box CPU of the whole box, but it's still utilizing the whole CPU of the box.
Okay, so allow me 2 minutes, Hari, to answer.
Okay.
Okay, see. So what I'm trying to say is, Hari, is that there are two things. When I say the SQL ID is using 40% of the CPU, fine, it might be using it. That's what I'm saying. It might have the bad plan. But considering, like let's say it's the best plan. You've done all the homework of best execution plan, statistics and fragmentation and all that. Everything you've done the homework, best plan and statistics, everything you've done that. SQL tuning, you've done that. And let's say just select star from table. Okay, for a moment, let's say. Now you are still saying, okay, you have this statement is a problem and it uses CPU 40% of the entire box, right? So of course, then you can, now there are two things. You want to give priority to this SQL or not. If you want, increase CPU share of this particular consumer group and user. Otherwise, if you don't want, you think it's bothering you completely, well, in Exadata, you can quarantine it first of all, and you can say, okay, if this is this much of elapsed time or CPU time, quarantine it. Second thing you can actually do is, if you think it's interrupting all the others guys, well, put a CPU capping then. If you think it's the priority, give it more priority in simple words. The third thing, which can be your box has limited CPU, right? You should add more is hardware to your box. That's the last thing which we can do. But it's a matter of CPU. So again, I hope my answer helped you, because that's what you can do actually.
Okay.
If
Okay.
it
Thank
has to
you.
use CPU anyway. Yeah. Next question, please.
Uh, Karan, we have a Kapil, and he's asking difference between ODA and the Exadata.
Okay. Hello, Kapil. So we have ODA, Oracle Database Appliance, and Exadata. So Oracle Database Appliance is for mid-sized customers where you have good hardware, but not exactly the modern hardware of Exadata, or the best in the world, I would say, of Exadata. So it's for mid-sized customers. It's Oracle's appliance, yes, good, but for mid-sized customers where you don't expect huge, extreme performance, amazing performance of the world, but it's for mid-sized customers.
Thank you, Karan.
Next question.
And we have a question from Mohammed. Can you please explain with the example about index, storage index, and smart scan collaboration?
Okay, so like I just mentioned a few minutes back, collaboration is not a good word here because they both are different things. So let's say, Mohammed, your query is using a query. I mean, your query is using a plan, and it's built on index, and you are good that it went, extremely fast with a smart scan rather than index scan. So just to define what a smart scan is, it is offloading. So that means most of your work will be done by a storage tier rather than the node or compute tier, database node tier, I would say, right? So it's offloading. Your functions are offloaded today. You can even check that in a VDollar view. There's a very good VDollar view that tells you which functions are offloadable. So most of the things today is offloadable. And when you get the data into the compute node from the database, from the storage tier, you would filter it. So if I say I want 100 GB of full table scan, all right, but from that 100 GB, let's say, I don't want to do a full table scan, but I just want to read 2 rows or one MB from 100 GB in simple words, all right? Dilly, can you go back to my smart scan slide, please?
Yeah, sure.
Yeah, it's just before that.
Is this one?
No, just before smart scan. There was one more. That's it. Perfect. No, second one. Yeah, that's it. Thank you. Thanks, Dilly. So if you can see here, when you go for execution plan, now check the note section. Can you see predicate information? Look at the storage clause here, storage customer valid A. You would see now, now let me tell you, even though a smart scan does not happen, you would still see a smart scan happening here, right? You would see table access storage full, right? So sometimes you see table access storage full, but actually smart scan does not happen. A smart scan will be declared only when you see storage customer validate, like this example. That's why I've highlighted in blue color here, right? So if these both blues are there, a smart scan happened. If the first blue is there, the bottom blue is not there, smart scan never happened. And the first blue will always be there, even though smart scan does not happen. What's that? Filtering the data. Instead of 100, now, Dilly, can you come to the next slide? Okay, next slide, one more. Next slide, this one, yeah. Check the status, yeah, this one. Check the statistics, right? Physical read total bytes is 18 GB. 18,000 MB means 18 GB. Now my table is 18 GB in size. And look at the second last statistics from self-physical IO interconnect bytes returned by smart scan. From 18 GB, we just return 120 MB to the database compute node tier, right? So from storage, instead of 18 GB, we just pull from the InfiniBand fabric or Rocky fabric, we just pull 120 MB only. And that is also proven by self-physical IO interconnect bytes, that we just pull 120 MB instead of 18 GB, right? That's a smart scan. You don't need index here, right? Now, I don't have a slide covering storage index statistics, but the good news is you have it here in the slide already, not highlighted, but third last, look at the third last statistic, self-physical IO bytes saved by storage index. Saved by storage index. So you did not get the benefit here of storage index, but you did get for smart scan. Probably because your query was executed for the first time. But let me tell you, your query will benefit usually from storage indexes when you say where column less than, greater than, minimum, max. Now you have in memory as well. In memory also has now in memory indexes, storage indexes kind of, because today when you select maximum column value from the table, the in-memory columnar store has max and minimum value in the memory itself of the compute node rather than storage. That's another thing, by the way, right? That's another cool thing about Oracle, a cool feature about Oracle. But what I'm trying to say is that you might get smart scan, but not storage index. You might get both of the worlds. So with the storage index, like I said, go back to basics. My initial introduction, what we tried to do was we eliminated allocation unit access. Okay, I am a student of this school. my classroom number is 5. I will skip classroom 1, 2, 3, and 4 and just go to 5. So how many classrooms I skipped? 4. Similarly, with the storage index, you skip allocation units. How do you skip that? We compare the column value from the in-memory index or storage index in the cell storage server, and we know that this particular column value does not lie in a particular allocation unit of the ASM. So that's why we don't bother to read that allocation unit, and we don't bother to read that allocation unit, right? So we save a lot of disk scans by getting rid of allocation units in the ASM. And smart scan is a different world altogether, that out of reading 100 GB from the disk, I just transfer 20 MB or 120 MB in this example to the database compute node. That's a different thing. Scanning a disk and how much data to pull from the disk is different things. Storage index is scanning the disk. Smart scan is how much data we are pulling from storage tier to the compute node, right? Let me repeat. Storage index is how much disk scanning you do. Smart scan is how much data you pull from storage tier to the compute node. Okay, well, that was a long explanation. I hope that helps you. Next question, please.
Okay, Karan, we have a Prabhas and he's asking, do ODA can have only 2 nodes or it can have many more nodes?
This is ODA related. This is I would say Exadata session, but I have not worked with ODA at all. So we are not ODA customers here. So I won't be able to answer ODA here. If you have Exadata relatives, please come up, guys.
No problem. Okay, Tarun has asked that what is the quarantine in Exadata? Does it mean if the query has a bad plan, so it will not execute further? Karan?
Yeah. So yeah, I thought we got disconnected. Yeah, there was a mute for some time. Yeah, cool. Okay, guys. Okay, so again, I think I already explained in this session that there are 2 kinds of quarantines. One is SQL plan quarantines. By the way, quarantine feature is only available in Exadata, by the way. Now, did you see my slide that we had course-based, quarantines and fine-grained, quarantines? Now, the difference is that sometimes your SQL misbehaves, probably because of a bug, and bug is not always. Maybe occasionally, once in a year, you hit it, or maybe once in a couple of years, right? So when you hit a particular problem with a SQL, only because it accesses a particular optimizer feature, let's say wrong results, that's a bug. Wrong results shown by the query is a bug, right? You would like to quarantine that plan, right? You can do that fine, but sometimes the SQL misbehaves with some Exadata features like cells or your Exadata specific software features, right? Or it misbehaves only when it accesses cell number 1 because of some problems in corruption, probably. So you would like to, quarantine cell 1 and use cell 2 mirror, ASM mirror, provided you have at least normal redundancy. So quarantine simply means getting rid of a problem, and it will not happen again. It will not use that particular option again, because you still have better options available in the world, right? If a query flips with a Bloom filter, returns bad, it's a bug, let's say, with a Bloom filter, you would like to go for alternate plan, right? There are other plans available, a little more expensive, let's say, but still you want, you want results rather than hitting a ORA error, internal errors and stuff like that. So in simple words, guys, quarantine still is a quarantine. So Exadata quarantines are still the same. And by the way, Exadata quarantines and SQL quarantines can be different as well, because you might want, to disable a particular feature in the cell software and get back to Oracle with a service request. So you can have a quarantine for that as well, right? So please write an email to me. I can share examples with you if you want, right? There are a lot of things which you can do with quarantines. Hope that helps. Next question, please.
Karan, we have one question that is, can you explain a called Bloom Pine Quarantine?
Okay. Dilli, has the mic properly audible?
Yeah, we can. Yeah, you are
Okay.
properly audible.
Oh, great. There's no disturbance, right?
Yeah. Yeah, someone has just accidentally unmute himself, so I mute him.
Oh, okay. Okay. So, is there any other question, Dilli?
Yeah, we have last one, but I think you have already responded. It's about the Bloom Pine Quarantine.
Okay. Yeah, I've already answered that. Thanks, Dilli. Firstly, guys, I would like to thank my friend Dilli. We first met
You are
in
welcome.
India. We met in India, Delhi, a long time back. Thanks so much, my friend, and it's been a pleasure to always work with you, whether it was a OCM project or any other. So stay in touch always, and guys, and so yeah.
Yes, yes.
Thank you so much, Dilli. It was amazing today.
And thank you, Karan, for your detailed webinar on Exadata X8M. And yeah, it's a very informative, and thank you so much for it.
Thank you, Dilli. Take care. Have a good day, everyone. Thank you, Dilli.
Take
Thank
care,
you, guys.
Bye, everyone. Thank you for
Thanks a
attending.
lot. Thanks, Karan. Thanks, everyone. Bye.
Bye-bye, guys.